Picture a scorching July day in 2023. Suddenly, a small South Korean lab claims the impossible, a material that conducts electricity with zero resistance, at room temperature. The material is called LK99. The world is electrified. Scientists, engineers, and science fans everywhere are buzzing. Social media explodes with videos of dark gray flakes, some appearing to float above magnets, a classic sign of superconductivity. The idea of a room temperature superconductor is the holy grail of physics, a breakthrough that could transform civilization. News spreads like wildfire. For a moment, everyone wonders, is this the discovery that will change everything? The initial research isn't in a famous journal, but online, for all to see. Labs worldwide, universities and even garage scientists rush to replicate the experiment. It's a rare moment. Open science, live, and global. People share results, failures, and ideas in real time. The world watches, hoping this little gray rock is the key to our future. The excitement is palpable, but skepticism lingers. The scientific process is on full display, messy, dramatic, and very human. For a few weeks, the dream of a new era feels within reach. Everyone asks, is it real? What does it mean for us? The LK99 story becomes a global event, uniting people in curiosity and hope. It's a reminder, science is an adventure, not just equations. The race to verify LK99 is on. The world is watching, waiting for the verdict. For a brief, shining moment, the future feels wide open. Why was everyone so excited? It comes down to electrical resistance. Imagine electrons as cars on a highway. In regular wires, the road is full of bumps and traffic jams. Energy is lost as heat. That's why your phone charger gets warm wasted energy from resistance. Across power lines, this loss is massive, like a leaky bucket spilling electricity before it reaches your home. We spend billions fighting resistance, building extra power plants, and cooling our devices. Resistance limits how small and powerful our electronics can be. It's a fundamental barrier, making technology less efficient and more costly. If we could eliminate resistance, it would be revolutionary. Imagine a perfect highway for electrons, no bumps, no jams, no wasted energy. Electricity could travel vast distances with zero loss. Computers could run thousands of times faster, without overheating. Machines from science fiction could become reality. This is the dream, a world without electrical resistance. The stakes are huge. Solving this would change everything. That's why the promise of a superconductor at room temperature is so electrifying. It's not just a scientific curiosity, it's a potential revolution. The world is hungry for this breakthrough. The answer to resistance? Superconductors. When cooled to extremely low temperatures, these materials lose all electrical resistance. Electrons flow freely, forever, with zero energy loss, a perfect frictionless superhighway. The secret is quantum mechanics. At low temperatures, electrons pair up into Cooper pairs. These pairs move in perfect harmony, gliding through the material without bumping into atoms. It's like having a VIP pass through traffic. Superconductors also repel magnetic fields, the Meissner effect, allowing them to levitate above magnets. This makes them powerful tools for technology. We already use them in MRI machines and particle accelerators, but there's a catch. They only work when they're extremely cold. That's why you don't see superconductors in everyday devices. The need for extreme cold limits their use. The dream is to find a superconductor that works at room temperature. That would unlock a new era of technology. The search continues. Superconductors are magical, but only in the deep freeze. The first, discovered in 1911, was mercury, which needed to be cooled to just above absolute zero. Achieving these temperatures requires rare, expensive liquid helium and complex machinery. That's why superconductors aren't in your phone or car. The cooling is just too costly. Over time, scientists found high-temperature superconductors, but they still need to be colder than Antarctica. Even with liquid nitrogen, we're far from room temperature. The ultimate goal is a superconductor that works at ambient conditions, room temperature and normal pressure. Imagine holding a wire in your hand that conducts electricity perfectly, no cooling required. Such a discovery would be a game-changer for technology and society. It's not just an improvement, it's a revolution. That's why the search is so intense. The stakes couldn't be higher. The world is waiting for the breakthrough. The quest for a practical superconductor continues. Back to the summer of 2023, LK99's recipe was simple, using common minerals and high heat. Labs everywhere tried to replicate it, sharing results online in real time. Some saw flakes levitate over magnets, fueling excitement, but careful experiments revealed problems. No true zero resistance. The levitation was just ferromagnetism, not superconductivity. The illusion faded as more data came in. By late August, consensus was clear. LK99 wasn't a room temperature superconductor. The initial claims were likely due to impurities and measurement errors. Disappointing? Yes, but it was science at its best, open, collaborative, and self-correcting. The world watched the scientific method in action. The dream was shelved, but the process inspired millions. LK99 showed how quickly science can test bold claims. It was a global experiment, unfolding live. The story wasn't a failure, it was a triumph of curiosity and rigor. Science moves forward even through disappointment. The search for the Holy Grail continues. While LK99 played out in public, another revolution was brewing: superhydrides. These materials, made from hydrogen and other elements under extreme pressure, have shattered records. In 2015, hydrogen-sulfur compounds superconducted at -70°C. By 2019, lanthanum hydride worked at -23°C, freezer temperatures. In 2020, a carbonaceous sulfur hydride hit 15°C, room temperature. So why isn't this everywhere? The catch-crushing Earth core level pressures are needed. Only tiny samples can be made, using diamond anvil cells. It's not practical for power lines or trains. Still, these discoveries prove room temperature superconductivity is possible. The challenge now: find a material that works at room temperature and normal pressure. The laws of physics allow it. The race is on to make it practical. The dream is closer than ever. Imagine tomorrow, a true practical room temperature superconductor is announced. The world would change overnight. Our power grid would become ultra-efficient, no more energy lost as heat. We could send solar power from deserts to cities across continents perfectly. Renewable energy would become far more practical, helping solve the climate crisis. Electronics would leap forward, computers thousands of times faster, no overheating. AI and data centers would explode in power and efficiency. Devices would last weeks on a single charge. New technologies would emerge: perfect energy storage, super efficient motors, and more. The way we generate, transport, and use energy would be transformed. It's not just an upgrade, it's a new paradigm. The impact would touch every part of our lives. A superconducting world is more powerful, efficient, and sustainable. The possibilities are endless. The future would be unrecognizable. Room temperature superconductors could make science fiction real. Maglev trains could float above tracks, traveling at incredible speeds with no friction. Cross-country trips in under an hour could become routine. Fusion reactors like ITER would be easier and cheaper to build, possibly unlocking limitless clean energy. MRI machines would become smaller, cheaper, and more powerful. Available in every clinic, medical imaging could become faster and more detailed. Quantum computers, now limited by extreme cooling, could become practical and widespread. Electric motors would be nearly 100% efficient, revolutionizing cars and appliances. Scientific instruments would reach new heights, exploring the universe and the quantum world. The discovery would unlock 1,000 new technologies. It's not just one breakthrough, it's a foundation for the future. Civilization would leap forward. The world would never be the same. The promise is staggering. all from a single material. LK-99's story ended in disappointment, but it reignited global excitement. For weeks, the world watched science unfold in real time. The process was a triumph. Open, rapid, and self-correcting, the dream of a room temperature superconductor is alive. Hydrides prove it's possible. Now, we need practicality. Thousands of scientists are searching, mixing new materials and running simulations. Each experiment brings us closer. This is one of the great scientific quests of our time. The reward, a turning point in human history. Stay curious. The next breakthrough could come from anywhere. The quest for a world without resistance continues. The journey is long, but the destination is worth it. Keep looking up.